Hi, Stefan. Hi, Lisa.
Hi.
Hey, let's do a quick check. Yeah, I can already hear you. That's nice. We are already streaming to YouTube, but we still have a few minutes to go. We will start at 5:30 with some community news, just as discussed. Stefan, do you want to say something too? So we know that audio works perfectly fine. No, we don't hear you.
I was
You're
muted,
still muted.
but you.
Nice.
Okay, you can hear me now.
Nice.
Great. Okay.
Very good. Lisa, do you know Stefan already?
I don't think we've met.
No, I don't think so either. I was in the same email thread, but it counts barely as knowing you.
Awesome. So Lisa, let me introduce you to Stefan. Stefan is also an organizer of the RUST MEETUP Linz. He's one of the co-founders. We did that together. So Stefan, Lisa, Stefan.
Hi. Nice to meet you.
Okay, awesome. So I will take us off the stage for the next few minutes, keep the community news slides still running, and we will start at 5:30, okay?
Got it.
Awesome. See you later.
See ya.
Oh, hi.
Hi, Stefan. And with that, I think it's time to get started. It's 5:30 sharp. So welcome to our next edition of the RUST MEETUP Meetup. We are going to start, as always, with some community news. So Stefan, let me bring the slides up to the screen. And here we are. This is a very special meetup. As you can see, it's the 10th meetup. Stefan, what do you say? We have reached
Wow,
a kind of
already?
anniversary.
Already. That went fast, didn't it?
Absolutely. I'm really looking forward to this. We only have 2 meetups to go, and then we have a full year.
Amazing.
I definitely think that we need some kind of birthday cake. I think I love cake, and I think we need something
absolutely.
like
A celebrations in order, definitely.
Let's see what we are going to be able to organize. So with that, let's go into the community news before we start right with our sessions. Okay, so here we are. Let me remind you that this meetup is brought to you by the Coding Club Linz. The Coding Club Linz is a club from people who are passionate about technology and coding. We are kind of foundation running various IT communities, including the Coding Club, including the Dojo Linz, which is a coding club for kids, and also this RUST Linz meetup. Now, yeah, okay, I can skip that because we already started. The reason why you are here are definitely our 2 great speakers. And Lisa Passing will start with the talk about creative Rust. We are looking forward to this session. And Harald REINGRUBER will tell us why they use Rust for medical visualization. Originally, we announced that Harald will do a presentation together with KATHARINA. Unfortunately, KATHARINA is sick, so Harald will do the presentation alone. Harald, please give KATHARINA our best wishes so that she will be well and healthy again very soon. Okay. As always, I would like to point your attention to our Discord server. Here is the link if you would like to join the discussions, if you would like to ask questions, if you would like to maybe exchange your ideas with our speakers and things like that. Please join our Discord server. Here is the join link, and I think it's a good idea to join the Discord link on the chat, so you can just click on it. We will do that in a few minutes. You can also find the Discord link on our homepage, which is rust-linz.at, so you can find it there. Join the discussions on Discord, and yeah, we hope that is a good platform for keeping in touch and asking and get answered some interesting Rust questions. Let me tell you a little bit about what's going on in the next few days and weeks in the Linz community. The first community news item is from our very own Dojo Linz, our programming club for kids. If you don't know the Dojo Linz, it's a programming club for kids between 8 and 17 years. It doesn't matter if the kids know anything about programming or coding already. If they are curious and want to learn how to build, I don't know, apps with Scratch, with block programming, or they want to do a little bit of text-based programming with languages like TypeScript or Java or things like that, they are invited to visit us in our programming club. The next online meeting is tomorrow, because we have online meetings and workshops every single Friday afternoon. If you want to know more about that, it's linz.codadojo.net, and there you can find all our workshops. Every workshop is marked with a recommended age group and recommended experience. So if you have kids who are interested in coding, tell them about the Dojo Linz. We would love to see them there. And times are changing. I was really looking forward to this slide for months now, because I can now already, for the first time in months, announce that there will be an in-person Dojo already. It is not a Dojo Linz. We will wait until autumn, but our colleagues, our friends from the Dojo Steyr will do their very first in-person meeting at the end of June, at the 25th of June. So if everything goes okay and the corona numbers will continue to get lower and lower, then we can celebrate the next in-person Dojo at the end of June. Hopefully it will work. Crossing fingers. We are really looking forward to see all the kids again in the Dojo Linz. Next, we would like to announce the next study group of our friends at Female Coders. Female Coders is a Linz community from girls and women who would like to start a career in IT, or who would simply like to enter the IT, learn a little bit about it, exchange ideas and thoughts, learn together, experiment together. And the Female Coders will have their next meeting at the 9th of June. It will also be an online meeting. I think they're also thinking about maybe meeting in person in June again. I'm not sure about their detailed plan. Please check out their website. You can find it at femalecoders.at, and there you can find all the details. They're also on Meetup, so if you are on Meetup, you can definitely check out the Female Coders Meetup site there, and maybe let yourself get notified whenever Female Coders announce a new meetup there. Here, I would like to pass on to Stefan, because he had an awesome idea for the next RUST Linz meetup. Stefan, tell us about it.
Exactly. So, yeah, the next RUST Linz meetup will happen on June 24th, but it will be a little bit different because we start at 10 p.m. Central European time. And the reasons are, first of all, my kids are asleep, so I have the chance to MC a whole edition again. But most of all, it's for us to accommodate our guests from New Zealand. So we will have two speakers from New Zealand. The first speaker will be Jonathan Turner, who has worked with Microsoft on TypeScript, with Mozilla on Rust, and is now working on New Shell. And they will tell us everything we need to know about New Shell. And the second speaker is Tim McNamara, who is the author of Rust in Action. He will tell us what he's going to show us pretty soon. So check out our meetup page or our rustlinz.at page. You will find all the talk details and speaker details. And if you can't make it until 10 p.m. because it's too late for you, don't worry. We stream, we keep the recording, we cut and repackage all the videos also again for the official Rust channel, so you won't miss out.
Stefan, I think that is an awesome idea, because we were in contact with some speakers like Jonathan and Tim for quite a while now, and it is always difficult to find a time. And I think a late evening Rust meetup is very interesting. It's awesome. I'm looking forward to the next meetup, which will take place in approximately a month on 24th of June. We will remind you of this meetup through meetup.com and, of course, through Twitter. Okay, and with that, I think I have, last but not least, sponsor news. We want to thank Microsoft. Microsoft is a sponsor, a regular sponsor of this meetup. They help us cover the costs that are associated with a meetup like that. And they, again, sponsored two meetups here in we promised them, and we do that very gladly because sponsors are important for communities, that they are offering so-called cloud transformation workshops. A lot of interesting information, a lot of interesting workshops regarding the Microsoft Azure cloud. Most of them are free, I think, if not all. Check them out. Here you see the URL, and I will again share the slides with you over the Discord channel. So if you have no possibility to write it down, you can click on the link in the PDF. And last but not least, Microsoft is regularly doing so-called dev talks. They invite some experts from the community to talk about topics which are important to them. I had the honor to be one of the guests a few months ago, and this is a regular series. So if you are interested in that, check out Azure Dev Talks, and we say thank you to our sponsor, Microsoft. And with that, we are at the end of our community news. Stefan, do you have anything to add? I think we are through. Did I forget something?
I'm just looking forward to our speakers. So those are two of my most favorite topics, and I can't wait to meet them.
Awesome. Okay, so let's bring first speaker, Lisa, onto the stage. Hi, Lisa.
Hello.
Thank you for being with us, and very warm welcome to the RUST Linz.
Thank you for the invitation. Thank you for having me.
Awesome.
Great.
Lisa, where do you broadcast from? Where do you live, or where are you currently?
I'm in Berlin, where I live and don't leave my house much. Just like the rest of us, I guess.
It's very similar to Linz. I hope the weather in Berlin is also pretty nice. Today in the evening we have sun and blue sky, and it's really a beautiful spring evening here in Linz.
We just had a thunderstorm in the afternoon, and it's very dark, so I had to turn on the lights actually because it's pretty dark.
That's it. You see, in Linz, the sun always shines. So when Corona is over and we do in-person Rust meetups, you definitely have to come to Linz and visit our beautiful city. And I promise it will be beautiful weather on that day. I hope so, at least.
That's a promise. Okay, I'm in. Sunshine, perfect.
Awesome. Lisa, the stage is yours. We will leave the stage now. I can share your monitor. Let me check that if technology works properly. No, it doesn't work yet. Do you already share?
Nope. Just
I see. Okay, that's the wrong monitor. Sorry, that was my mistake. And now we are here, and I will add it to the stream. Yes.
Okay.
That looks good.
Slides.
Yes, we see your slides. Okay, great. We are looking forward to your talk. Lisa, if there are any questions, should I relay them to you if they are fitting to your talk, or do you want to take questions at the end? What would you prefer?
I have a lot of talking to do, so I think all
let's do it at
the end. Yes.
That is
but then
awesome.
We can talk all about all the questions.
Very good. Lisa, the stage is yours.
Thank you very much. Okay, so this is Creative Rust. I'm super glad to be here. Thank you very much. Just really quickly about me, because I actually do have a lot of talking to do. But I want to get this out of the way. I'm Lisa, or Liz. If you want to search for me online, this is probably the name you want to search for. And I'm a creative technologist based in Berlin. What does creative technologist mean? That's a very good question. I'm still struggling with a good definition. But I like to think of it as finding solutions to more creative problems, and not maybe your everyday, day-to-day kind of technical problems. But let's see how that goes in the future. I'm still pretty new to it. And obviously, I like Rust. And these things together combined are more than enough reason for me to talk about creative coding in Rust. Since this is a Rust meetup, I don't think I have to do any language evangelism. And instead, I can focus on creative coding. Which might be something that not a lot of people or everybody is familiar with. And it's also a very a broad field. There's a lot of things that go into it. So I want to take a couple of minutes in the beginning to kind of look at the different parts that make up the world of creative coding, because I think it's super exciting, or at least it's very exciting to me. Let's start with a quote or a definition, because it's always a good place to start. So Wikipedia says that creative coding is basically about creating something that is expressive instead of something that is functional. And I really, really, really like this because it liberates us from this idea of that we have to code something that runs and that works, and that it has this single purpose, and if the code doesn't run, it's useless. And creative coding says whatever, as long as as long as it expresses an experience or a feeling or anything you want to express, you have creative coded. And I think this is already okay, we're free to do whatever we want. And this is I can already feel I can breathe more freely after knowing this. So there are no mistakes. Perfect. Aside from this more headspace that I really like about creative coding, there's obviously a lot of very fascinating and cool technology that we get to play with if we want to dig deeper into creative coding. And I had a hard time in the beginning as well, wrapping my head around, okay, what are all the parts that make up creative coding, and what is all the things that is interesting and that is interesting for me specifically. And the list that you see is compiled from a little diagram that I came across when I watched a webinar by Luis Ferreira, and I thought this is really cool because it kind of maps out the different areas quite nicely. And I want to give you a little whirlwind tour of the things here on the list, because if you deal with creative coding, you can work with artificial intelligence, especially things like generative adversarial networks, or GANs. Are things that constantly blow my mind, these more anatomical, nature-inspired things that Sofia Crespo generates. There's this entire realm of physical computing where you get to play with sensors and motors, so take in input from the environment and then act out on the environment, or things like pen plotters, or anything that makes makes its way from the digital back into like the physical realm. Like it's super cool. It's super exciting. Electronics is like a big part of like what I spend a lot of my free time on. But there's also like other cool stuff in the more like audiovisual, like actual performing in front of people thing. As an example, I picked like live coding or Algorave, where you can code music, you can like have actual musicians like perform with you on stage, and like it's really so much to do and so much to see, all the way up to light art. I picked as an example projection mapping, where you can write visuals and like code like project imagery onto buildings or facades and like make it match the actual architecture. You can have this like animated or like also interactive, and it's like really it's so cool when you stand in front of it and you know that like people made this and like interact like digitally with like things that exist in the real world. Okay, I just like throw a lot of things onto you, so just so you have like at least one image in your head for all of these points. But the main part that I want to like dig a little bit deeper here is the generative art stuff. It's also, I think, like the easiest to get started with, because you don't need a lot of like equipment or like anything else. You don't need the hardware. You don't need buildings to project things onto. What you need is your computer. Perfect. So generative art. So we from all of creative coding, we're now in like generative art, and there's also like a lot of stuff, or like a lot of areas within generative art that you can look at. Like it's really just like it can be data driven, it can be real time. There's lots of things that are happening, but it's like again a little definition maybe to work with. Like, what does generative art even mean? When we talk about generative art, we talk about art that is created by a system where the system has some level of autonomy, or like the artist does not intervene directly in a way with the art that is being produced. Because the artist in like the world of like generative art is the person that designs the system or lays down the rules by which the system then generates the art. So we have this kind of like rule system, and then like this based on these rules, art is created, and we define the rules. So this is really cool. Let's look at some examples, because generative art is not just computer visual art, the way that we will do it later, but it has or is applied in lots of different fields. For example, architecture. Here's an example where from like a grotesque style inspired not installation, but like it is 3D printed and then glued together and like fills entire rooms, and it's all like it was generated by a computer and then pieced together by the humans. There's obviously literature and poetry. Here I have an example from a French collective that already generated poetry back in the 60s, and the way that they wrote 10 sonnets, but like cut out the individual lines of the sonnet and put it in a book. And when you opened the book, the individual lines in the poem would like just like open in a random way once you open the book, and what you get is a randomly generated sonnet. And since they had like 10 sonnets, and it just like varied, like it was completely random at which they in which order these lines would fall. So they basically already generated poetry in the 60s without computer, purely like analog. And I think this is really cool, because we still are within the realm of this where the artist just gives you the rules, and then the system follows the rules and generates the art for you. We also have like generative art in music. Maybe most famously Brian Eno and the music for airports, which is like this very ambient, slow sound. But again, he just set like the stage of like, here's the rules by which the system then determines which note is played next, and this could actually be played until like forever and ever in infinity. And this was like already in the 70s, which I also think is like cool. There's so much history there already. And then like a more recent example of like more like the visual art stuff that you probably like, or like maybe see on social media or something. Here I picked some like imageries from an artist called Monoloid, who posts like on Instagram and Twitter, I think. And this is just a screenshot of his Behance page. Some like really cool stuff. You can see like how he's like trying to imitate brush strokes and stuff, and it's so fascinating, and it's really, really cool. And I thought this is like more into the direction that I want to get, even though we will not get as fancy. Sorry, time limits and stuff. But I like chose these examples to be a little bit all over the place on purpose, because they have this. I want to get this feeling across that we can definitely like learn from what came before us, because we have so maybe one step back, if we free ourselves from this like idea that we write code that has to solve a specific problem and it has to be functional, we have to like think of like, okay, it has to work now, and this is like what the thing that we code for. But in a more creative and expressive environment, we can maybe say, hey, the output or the feeling and the sentiment and what we created is more important than the tech that we used for it, or that we don't have to ensure that it keeps running forever, as long as like it ran maybe once and it created something, or it never ran, because maybe we do an art installation about error messages and then the point is that it never ran, or something along those lines. And I like the other part is that I think it's so cool. So like why I also picked some stuff from like the 70s or the 60s is that I feel like there's more history to what we do than usually in tech. Usually it's like, oh, this framework is already 3 years old. Wow, it's so mature. But like with art, we have this like, we have this context of like, culture in a way already, that we can say it's like, okay, people have done this like 50 years ago. And I really enjoy this way of thinking of like, not everything we do is new. It's always been done before, but we can still learn and be inspired by the people who came before us. With that being said, I want to talk about a person that really inspired me in the last couple of weeks, which is who is Vera Molnar, and she gets the super cool title on Wikipedia. Pioneer of computer art, which is like, yes, if you get that title, I'm like, wow, you've done it. And she is really cool. She was born in 1924. And she's still alive, and she is still working at like almost 100 years of age, which is mind-blowing. Like definitely life goals to achieve there. And she was born in Hungary, where she studied like art and art history. So she's like an actually like classically trained artist. But then in the 50s and 60s, she moved to Paris, where she thought of this the system by which she started to create art, which she called méthode imaginaire, which is basically exactly generative art. So she thought of like a rule system, for example, a certain grid and certain colors, and then certain rules by which these were like applied, and then created art based on the rules that she first thought of. So like basically generative art, except she didn't have a computer. But then once in the 60s, late 60s, computers were kind of more available-ish, at least to some people. The first thing that she did was make art with it. Really, really cool, like a real like pioneer. And what is also cool, I think, is not only that she started making art, but the way she brought the art, or like the computer generated stuff, back into the real world is through the use of pen plotters. So you get like actual pens drawing the generated art. And you get this kind of like, yes, a computer thought of these forms, but you get this like actual ink on paper kind of real world, physical, tangible experience, which is really, really cool. And she's already like in this like, if you remember the creative coding techniques in the beginning, she's already like combining like the physical computing part, which is pen plotters, with like her generative art already crossing through all the sections that we get. So this is already super exciting. I'm really, really, really so in love with her and the work that she did. Let's look at some examples. So one of her earlier works here is Interruptions, which she already did in the late 60s. And I think it's just super timeless. This is like something that is just so cool. Like it's really simple, and it could still be something that people would generate today, or think of like, okay, how can I write a system that generates this kind of output? Very cool. Another famous one of her works is called Disorder. Sorry, like French native speakers. Which is like a series of like where she really looks into like this random rectangles on grids kind of thing. This is also like a very famous example that you see often if you look into tutorials on creative coding, or like where to get started, is like this idea of figuring out what people did who have done this like decades ago. So this artist is a pretty good one. And then like from the 80s, there's another like pen plotter print here. It's called, like from a series called Structure de quadrilatère, or square structures. And when I saw this, I was really like, this is kind of like really cool. Like this one really spoke to me on some level. And I'm not really sure why. But I decided that this should be the piece that maybe we can look at together and see how we can implement something like that in Rust. So now that I like threw a bunch of words and pictures and like a whole lot of input into your all's faces, let's talk a little about Rust and creative coding in Rust. I want to use a tool or like a framework that is called nannou. It's probably the most mature creative coding framework written in Rust right now, at least that I'm aware of. And it's really cool because it's fairly young, but it like learned a lot from like the other creative coding frameworks out there, like processing or open frameworks, but also making some decisions that are very like future oriented in a way. So I'm like very excited about like all the features that are still to come, but it's already like in a super usable place right now, which is why we're going to use it. So the plan is taking this piece, Square Structures by Vera Molnar, and trying to implement something or like recode it in nannou. So we should make a plan. Okay, so let's assume that we're new to nannou and we don't really know what we're up for. So the first thing I would look is like what we have. nannou has a template that we can use. We can check it out, get a little bit familiar with the idea and the structure and everything. Then obviously we have to find out or figure out how we can draw a random rectangle. Because this is, if we look at the thing, we have like, if we look at the original image, we have a rectangle that is made up of a grid of various random rectangles in different colors. So first we figure out how to draw one rectangle. Then we need to figure out how to draw a grid of random rectangles. I would choose picking colors next, but that's just my preference. This step could probably also go at the beginning or at the very end. And then I would say, so assuming that first we start with just a grid of a rectangle each, then assign the colors, and then per position in this grid, I want to draw multiple iterations or like multiple versions of or like just multiple rectangles in the same position on top of each other. And then I actually want to add some interactions because I really like playing with the stuff, like not just like generate it once, the way you would do it and then print it or plot it out. But we have like, since we're staying digital for now, have the opportunity to play with things, just like play with the parameters and like have a little bit of fun with it, because that's the point, having fun and learning stuff. Okay, with that being said, let's draw some squares. And I have a slide intentionally left blank, so I have time to switch over to other stuff here. Okay. So these examples that I'm going to show you, they're already online on GitHub in the repository that together there's the slides that I showed you, or they're already online. And these examples with each step that I'm going through in a separate file, so you can like with comments, and there's also README. So if you want to like, if this is all very fast, and I realize it's very fast, you can like read through everything at your own pace later on, and hopefully it all works for you. It's not rocket science, I assure you. Okay, with that being said, the first step is looking at what we have. So the code that you see here is the example app template. So in the nannou repository, there is a folder called examples, and there's another folder inside that's called templates, where you find the app template. And this is the entire app template. And this is a fully functional nannou app. If we run this now, let's see. So this is called step 1 in the repository. If we run this, we get, this is the standard template, or the standard app template. It's just a window that draws a circle in the center of the screen. Nothing too exciting at first, but it's already pretty cool that with like really very little code, we already get this kind of output. So let's see how this works exactly. We get the nannou prelude. In the main function, we just like kick off this app. We don't actually have to look at this anymore. Just like this is where things go together and then start up. The most important, or like the things that are like interesting to us are a struct that is called model, a function that is called model, a function called update, and a function called view. If you hear the words like model and view, probably the association that you first have is like model view controller. And if that's the case, you're right on the spot, or like just right, because this is kind of like the overall architecture that nannou was built with. So like model view controller, where model holds your state, and view is kind of like just the visual representation of your state. But we don't really have a controller. We have more of this like the logic of like updating the state as you go, and then having the state represented. If you've maybe like played with things like processing before, or maybe like other game engines even, you might wonder, because like view is like, for me it was like a little bit unusual. The view is usually called something like draw, just like making clear that this is where like the drawing happens onto the screen. But it's also like it makes a lot of sense if you think of it from this like model view controller perspective. The other part is that the function that is usually called setup or sometimes load. So the first, like all the code that runs once in the beginning to set everything up is actually called model in nannou. This is where the window is created, and the model, like as our container for our state, is initialized, or like is instantiated, I guess. With that being said, this is what we have. We have the model struct that defines our app state. The model function creates the window, initializes the model. Update would be a function that continuously runs to like update the model, and view is a function that continuously runs to draw to our screen. Cool. So this is what we start with. And let's see. So this is step one. Step one is just like looking at stuff. Let's see how step two works. So step two goes from drawing a circle to drawing a random rectangle. This one's pretty ugly, but this is what you get when you draw random stuff. Let's run it again. More like it. So this is one way to draw a rectangle, just in the center of the screen. Let's see how this could work, or this could look like in let's look at step two. The only like really interesting part here is, and I will just really superficially run over the changes, but there's not, don't worry if not everything like falls into place right away, is that in our model struct added points, which is a vector of two-dimensional vectors. So like two-dimensional vector is something with x and y coordinates, for example, so like a position in space. And so I just like collect all these points, and they will later make up the points that define the rectangle. And then just in the, I started with just here in the model function. So like, okay, if I need like a list of points that define my my rectangle, I can start with an empty vector, generate a couple of points, push them into the vector, and that's it. Maybe to note here is that I push point number one twice in there, because the function that I use to draw the stuff is called is a polyline, which is technically only a line. So I have to like put in the beginning point twice, so it actually closes the entire thing. But that's just like to note here. And the way that I kind of like distribute the points and the rectangle to get a rectangle is that I like use a random function. So in this case, random float 32. So like I get something between 0.0 and 1.0, and then multiply this by the maximum width and height restrictions that I want my rectangle to have. So let's say maximum like width and height of like 100 in this case. So I get like something in between, and then I use like negative values on the individual corners to kind of like push them out so that I don't get like, how would you say it? Just like a random lump of points that doesn't like, may have like 4 corners in a way, but is not really rectangly shaped. And with this, I can like kind of like pull this a little bit out, so I get something that is more or like resembles more like a rectangle that you would imagine if you just think of like, oh yeah, a rectangle. With that, and then let's quickly look at like how we actually draw the thing. I removed the part that draws the ellipse or like the circle that we saw, and actually draw a polyline, give it a color, and give it a weight, which is the width or the stroke width of the lines that we're drawing, and then I give it all the points that we just created. These are like in our model points vector that I have to clone because points wants to take ownership here. So if you run this and like maybe like code it at some point and you're like, why doesn't points like I get a compiler error? Maybe clone this because some of the functions actually want to take ownership, and in the view we can't. We only have like an immutable reference to our model. Okay. With that being said, so I'm quickly gonna like quickly running this again. So we now have like one random rectangle, even though this also looks kind of like a triangle because smaller sides, but that's okay. From here on, we can like move on to step 3, which is drawing a grid of these random rectangles. This is already kind of like stylish in its own way, kind of like pop artsy. Let's see how we can do that. Look into the next step, step 3. I'll define like a couple of like magic numbers that I need for the grid and everything else on the top. But in this step, what is kind of like the biggest part is that I kind of like started to abstract introduce more abstract concepts of like the way that I want to organize the code. So maybe I pull this up again to better explain. So I thought that I want to have a structure that I call square structure, because that's kind of like the name of the art piece, and that each structure represents one position in the grid, and that later holds the color, and then also all the individual rectangles that are drawn on this position. So in the end, we will have like a vector of square structures that represent the grid, where each structure sits on one position, has a color, and then also all the rectangles that are drawn on that position. But first things first, in the first step, I just want to have the position, which is again like a 2-dimensional vector, and then the points that we previously had, except that previously we just had one points vector just directly on the model, and now just like push it into this, or like reassign it to the square structures struct. Okay, then just impl square structures. This is the same points code that generates like a random rectangle, and then I calculate the position based on the position in the grid with a little bit of nudging in the coordinate system to kind of center it. Let's go here. Write a little function that is just 2 nested for loops because it's simple and it just works over the ranges that I want my grid to have. I think I said in this case it's 7 by 9. Generate a new structure, push these structures into a vector, and then we can have this vector of square structures in our model. So here's where I call it. Here's where I put it into my model. And then in the view, we basically iterate over the structures in our model and draw this polyline. We now have this new X and Y where we actually have to like specify the position, but the rest pretty much stays the same. Cool. On to the next step, where I randomly put color here because I wanted to now get away from just as like the original purple and steel blue, I think they're called, or plum and steel blue, to like more into the direction of the colors that Vera used in her sketch. So this is going to be the next step that we try. Just like per each structure, also have a color. This is pretty straightforward. I actually also added the rand crate, so I get like a nice API for like choosing a random thing from a vector. Also pull in a nannou color. And then on the square structure struct, I can say, hey, we will now also like have a color. And the entire magic, or the biggest part of this, is like this rando color function that just defines this like predefined vector of color. So I want to have like actually like a lot of say in these are the only colors that I want to use. But this could also be like a cool entrance point for saying like playing actually with the color composition in the piece, of saying like, hey, maybe instead of RGB, we want to like use HSL, and then play with like maybe the saturation levels or the hue, anything like that. So this could be like a nice place, but I chose to keep it simple here, just have predefined colors, and then choose a random color from there, and then assign it to the struct. And then when we draw it, I just like, previously we only had steel blue, and then say, hey, now each structure has its own color, please draw this. Boom. And this was it for color, and we're almost there, because in the next step, where things go a little bit crazier, is where per each structure, we now not only draw one rectangle, we draw multiple. But with everything like we already have like put in place, this is actually quite simple for us to achieve. Okay, let's see. Or is it simple? Let's find out. I defined another value up here, which is just like the maximum number of rectangles I want to like, or like squares that I want to draw per structure in the grid. And I also decided to add another layer of maybe abstraction, if you want. Added a new struct that I just called square, which is just now holding the points for each square. So like I'm basically just pushing around this the initial idea of how do I draw a random rectangle, and now it lives just inside square, and square structure gets in turn a collection of squares. So the square structure has a position in the grid, and a collection of squares that are like drawn on top of each other, and they all share the same color. Cool. Which then in turn, that just, so maybe one more step is that now when we generate, or like when we create a new square structure, I also say like, hey, for each structure, fill this vector with a new square. And then when we draw it, it's just another nested for loop for drawing. And this is it. And it was actually not that much code to like get to this visual effect now, because in the end it was fairly simple. If we think about it. Whoop. So with step 5, we're kind of like there-ish, I would say. So we could play with like some of like the magic numbers that I defined at the top to like maybe widen or constrain like the rectangles a little bit more, maybe the number of iterations. But I actually wanted to have some sort of interactivity, because there's a couple of things that I definitely want to play with when I saw this first, which is, for one, changing the color, so like the color assignments of the different structures, but then also the number of rectangles that are drawn per structure. And I thought like, okay, I kind of want to maybe play with 3 aspects of the thing, and I have a 3-button mouse, so let's like put some of like the events on mouse interaction so we can play with it a little bit, which is going to be the last step that we look at. So first it looks kind of like the same, but when I click with my left mouse, I basically regenerate all the squares that are drawn, but the colors stay the same. But with the right button click, I can like assign the colors or reassign the colors, but the positions stay the same. And when I scroll, I can reduce or increase the number of the rectangles that are actually drawn, or like the squares that are actually drawn per structure. So like if I go all the way down to 1, I can, we're kind of like stepping back to the initial step that we had, but then I can also like decide on like how many lines I actually want to have, and like then choose something that I think looks kind of good. Maybe something like this, maybe a little more. So let's see how we can do this, because actually events are handled really nicely in nannou. I'm a big fan. Let's see where we go. Let's go here in our model function, where the nannou window itself is created. And here we can register the events that we want to look out for. I chose mouse released, so like when the mouse button is click but release out, and mouse wheel, which is when you scroll. And then these just get like the functions that should be called when these events happen. So let's look at mouse released, which is this one. And the interesting argument that we get here is button, which is of type mouse button, which we can match on. So we have mouse button left and mouse button left and mouse button right. And then I can just say, I also have access to my model here. We get a mutable reference to our model here, so I can like also update my state. So I can say, so for left mouse click, I iterate over my structures, and I also defined a function that I'm not explicitly going to look at here, but just basically regenerate all the points in all of the structures, so like the squares actually. And on the right button click, I also iterate over it, but call something that is called set color, which just picks another random color from the predefined vector. And then I don't even have to touch the rest, because the rest just trickles down into the visual representation. The other part is here, mouse wheel, where the interesting argument is dt or delta, kind of like the difference in like the mouse position or the mouse scrolling, where we can also match on mouse scroll delta line delta, which is a tuple of like x and y, so like, because in theory you could scroll horizontally and vertically, but I'm only interested in the vertical scroll, so I'm only like on only like the structure for y here. And the other funny thing is that y is either a negative 1.0 or a positive 1.0, depending on whether you scroll up or down. So I have a little guard here to tell me actually in which direction are we now scrolling. Then I have a little bit of a setting boundaries, because I actually don't want it to go out of hand. So like a maximum number of 10 is what I defined, and at least 1, otherwise the sketch breaks. And then I count up and down another. This is just like a little property on the model that globally defines how many squares I want to draw. And then as for the drawing itself, I can like make use of a nice or like more of like the functional features of Rust, because in the iteration loop where the actual squares are drawn, I can simply say like take and then this global number of squares that exist, and just draw this amount and don't really care about the rest. And I thought that was really cool. For the sake of time, I don't want to like get into some of the other, like I feel like in this part it's really like cool, like the things that Rust gives us for like handling stuff like this, like especially pattern matching and some of the functional things are so nice to work with in Rust. And if I think about like some of the stuff that I did in processing or in P5, where it's like kind of like always a little bit more complex, I feel like working with this in nannou is like really a smooth experience. So that was really cool. And that was a whirlwind tour of how to get something like Vera Molnar's square structures thing, but like implemented in nannou, just to give you a little bit of an insight into how you could like plan out the way, like a little journey on where to go and like maybe what to think of. And then in the end, it's really small incremental steps that get you there. And with this, I want to like already like kind of like go into like a little wrap up, because yeah, there's so much to talk about and so much to learn. So I prepared a resources slide. I actually have 2 resources slides. One is just like Rust and nannou specifically. There's a nannou guide, which is probably like also like a very good way to like get familiar with some of the concepts behind nannou, especially like about the coordinate system and how like drawing works. But then there's also like another generative art tutorial that is pretty new, where you recreate gravel or shutter, which is another like a piece that you maybe have seen. It's also like one of like the first things that you learn when you like a lot of tutorials take this on as like a first project for generative art. So there's a tutorial for that. And I also want to highlight a session by Alexis Andre, who did all the sketches that are on the nannou website, so all the cool animated stuff is Alexis Andre's work, and he gave a session at GitHub Universe about nannou and creative coding in Rust. And this is like also like it's 30 minutes, it's very, very cool, and also like gives you a little good insight into like how he thinks. I think I really enjoyed it. And then more links, but I'm not going to talk about all of them. There's another resources slide with just more generative art things. So you have like, if you planned on sleeping tonight, maybe don't sleep and read through all this stuff, because it's at least as interesting as sleeping. And with that, I'm actually at the end. Thank you for listening to me. Yeah, and that is it. And then we can do questions, I guess.
Awesome. Thank you very much, Lisa. It was an awesome presentation, and I can't put it any better than Carl did on Discord. He wrote, "I'm really inspired, and now I have something to do for my vacation next week." Really amazing. So yes, absolutely. It was a very good presentation. Thank you very much. We have some questions. In fact, let me show you the first one. This one. Now, Rengare, I'm not sure if I pronounced the name correctly, asks, is the image responsive? That is, if you expand or shrink, I guess he means the window, will the rectangle change size?
So the way that I code, so good question. The window itself, you can just like resize freely. The way that I coded it right now, it's not responsive, but you do get, for example, the way that I registered the mouse events, there's also an event called it's either resize or window resize, where you can actually like then get the chance to update the like all of the measurements in your sketch based on what happens in this resize. So you can, the way I coded it, it's not, but there's definitely tools to make it.
Okay, thank you very much. The next question comes from Stefan. He asked whether nannou would have some APIs to also generate video or image files, or maybe even have APIs for sound.
Also very good question. So the video parts are still, let's say, in development. There is a feature to like save images as like basically screenshot your sketch, so like save what you have as a file. That exists. The video stuff is it's still like a very young framework. It's definitely in there, like the entire like range of video, and then also video manipulation and all the stuff that comes with video. I'm not great with video, so I didn't actually look like too much into it. And now I forgot the second part of the question.
It was about sound.
It was about sound. Sound is really interesting. So there's already like APIs for the OSC, open sound control thing. So if like there's no synth. Oh, now I have to think. I think there's no synthesizer or like anything that actually synthesizes sound in nannou. But if you want to like have your nannou sketch interact with external things like MIDI controllers or anything else that speaks OSC, this is already possible.
Interesting. Yeah. Next question we have from Harald. He asks whether you know which graphics APIs or crates are used by nannou in the background.
That's a good question. I'm not like a super graphics crack, but the nannou tries to like use the most like advanced or like state of the art kind of like APIs. So they're working very hard on the like Vulkan and what's the new thing called Web GPU. So like basically all like the new super exciting yay. We try to squeeze as much performance out of our graphics cards as possible. Also preparing stuff for like WebAssembly. So like everything is pulled into it. They're working hard on this. They're also contributing to like the Web GPU crate. Again, I'm not like super duper into the graphic stuff, but it should be fairly cutting edge, I would say.
Okay, thank you very much. The next question, I'm not 100% sure if I fully understand it. The question was the backend of Blender 3D technique. Shall we call it as generative art? Can you interpret this question?
So there is. So my interpretation of this question is: you can do. Can you do creative coding with Blender? Mm-hmm. Yes, you can. All of like the like Blender has like so many like functionality around like generating various like visual effects for like 3D stuff. So if you're talking about that, and if you're playing around with that and then like generate beautiful like 3D imagery or like 3D models, this is definitely creative coding, because this is also like the next step would be then like or like for me is like to then 3D print this stuff, or there's like so many things that where people like actually have to like generate like models that like then like could be jewelry, could be installation pieces, anything. So is Blender a creative coding tool? Definitely.
Okay, interesting. I would like to ask a question too. Maybe you have listened to the community news that we did at the beginning, so then you know that we do a lot of work with kids. And when we work with kids and teach them the first steps in textual programming, we mainly rely on P5. We love P5, and the kids love P5 because we build simple games with them.
Yeah.
Is nannou a platform for building a simple game, like a classic arcade game or something like this?
You can probably. I actually have not made a game in nannou yet, which I probably should do. There's definitely like if you can make a game with P5, like nannou has the same kind, like the basic textual things. You can build this with nannou, like a snake game or Tetris or something, or Breakout. Like is Breakout the standard game that like just a little 2D, like I walk around, collect things.
Yeah.
Absolutely.
Nowadays, all the things that you mentioned, we already built it. So we built Snake, we'll build Breakout, we built the obvious Dino Run and things like that. So yeah, we will definitely check it out. Maybe that will be an interesting extension to what we do at Codedojo. Lisa,
maybe one more addition. So nannou doesn't feature WebAssembly yet, but it will come up. So like ultimately in a couple of months you will be able to like write it and then also have it run in the browser, and then I don't know, I also really like P5, but like maybe you don't need P5 anymore.
Yeah. Okay. I will definitely give it that. Thank you very much. Lisa, I would like to close with one important information that I would like to first give you or ask you. Have you ever been in Linz before?
No.
Do you know that Linz hosts the Ars Electronica Festival, which is one of the largest electronic arts festivals in the world, with hundreds, if not thousands of artists over the years? It started already in 1979. And while you were talking, I was, of course, Googling. Vera Molnar was, in fact, at the first Ars Electronica Festival in 1979.
Of course, I know Ars Electronica, but I did not actually make the Linz connection. That is fascinating.
So maybe we will find a possibility for a RUST Linz meetup at the time when the Ars Electronica Festival will be there, and then you can visit this city, take a look at Ars Electronica, and do another talk here at the RUST.
I would love to.
Awesome. That would be awesome. Thank you very much. Thank you for being here, and thank you for this great talk. Are you on our Discord server?
Not yet. I was too nervous to do that, but I will do it now while I listen.
Yeah, if you want, that would be awesome. Maybe some people have questions. If you like, you are always very welcome there. So, thank you, Lisa.
Thank you.
Have a nice evening. And with that, we come to our second speaker. Let's bring Harald to the stage. Hello, Harald. Can you hear me?
Hello. Yeah, loud and clear.
Hi, very good, very good. I already asked Lisa the question, and I ask you the same question. Where are you broadcasting from? Where are you from?
Broadcasting from Scharnstein, Upper Austria.
In fact, you are nearly a neighbor. You are near to Linz, right? Okay, very good. It was originally planned that you do the presentation together with KATHARINA. You told us that she is unfortunately sick. Please tell us our best wishes. I think she's sick, but it's a good reason to be sick, right? Because I heard she got her vaccination or something like this. So that we definitely know how that feels. Okay.
Yeah, get well soon, Katharina. Thanks for supporting me and preparing the presentation together with me. Yeah, a huge credits also go out to Katharina for all the work we did together.
Awesome, awesome. Thank you very much. Harald, I think we are perfectly in time. It's 6:30, so the stage is yours, and we are very much looking forward to your talk.
Okay, great. Yeah, just wanted to say it's cool that we have a second talk kind of related to visual computing. It's also one of my favorite topics, and I think it goes well together. Creative coding, medical visualization. It's different, but it's kind of similar as well. And I really enjoyed the first talk of Lisa as well. Okay, so I want to present to you what we are doing with Rust for medical visualization. We basically started a few months ago working with Rust, so it will be more an experience report of what we learned and how we approached our journey into Rust. So I guess from all the technical details, I probably could learn even more from the audience, but still, yeah, I think there are some really interesting things we found out so far. Yeah, thanks for Katharina also for all the great work and the collaboration and the preparation for the presentation. We work for Dedalus. We are kind of the 3D visualization team at Dedalus Healthcare. And basically what I want to show you today is what we did achieve so far. What we want to achieve, what our goals are basically, what we did find out so far, and why we chose Rust, why we think Rust is great for our goals. So what do we want to achieve? This is our current desktop application, and it's showing the 3D volume visualization module. On the left-hand side, you see the actual volume rendering. On the right-hand side, this is the multi-planar reconstruction. So it's basically the 2D images, a 2D reconstruction of the orthogonal axis of the 3D volume. So how does the data look like? If you get a CAT scan or an MR scan in the hospital, the 2D slices, the images are taken, and the DICOM format, which is a popular or the main format for radiology image data, stores all the data in 2D images, and these can be reconstructed, can be visualized as a 3D volume, which is basically a stack of 2D images, and where each pixel is called a voxel. Yeah. And volume rendering works by shooting rays through every pixel of the screen through the 3D volume. So yeah, you can imagine it like this. You have like a virtual camera which goes through your screen plane, and then you check all the voxels along the ray, the intensity values, and this way you can create a 3D image from the 2D data initially. So we looked at our requirements, and the most important requirements were it should run the new we want to recreate this module, and the new module should not only run in the desktop but also in the web browser. It should be able to visualize the things on the GPU, but maybe in the future also with the CPU. And right now we are focusing on the client side, but maybe later we want also to move it to the server side as well. And yeah, I also wanted to mention why the web platform is interesting to us. So right now you need highly special to view the radiology data. You need highly specialized software, but we want to get away from that as well. There should be better access from departments outside of radiology, which does not have this specialized software. And also we want to support tablet devices because this way it is easier to show reports to patients. And probably sooner or later, also access to medical data should be possible by the patients themselves over the web. So what did we find out? We decided to do a proof of concept, and we wanted to also look into alternatives than C++, because the obvious choice would have been recreating the 3D module with C++. We also wanted to check if all the critical requirements are technically supported by the technology stack we choose. And we wanted to get familiar with the technology stack. So we decided we want to do a basic visualization on the GPU. The most simple technique would be the multiplanar reconstruction because it's mainly 2D. But we also wanted to do get some experience for the performance of the technology. So that's why we decided the maximum intensity projection is often used for 3D visualization as well, but it can also be used for the 2D reconstructions where you just create one image out of multiple 2D slices. It's kind of a thick slice, so to say. And we also wanted to do some basic interaction so that you can get a feeling for how responsive it is. So, and there we decided to do just a simple scrolling through the 2D reconstruction. So basically we wanted to compare C++ with Rust. So we did 2 prototypes. And for each of them, we tried to also generate WebAssembly code. And in the desktop version, we use OpenGL for the visualization, and in the browser version, it should use WebGL for the visualization. So yeah, here you see the result of our basic C++ prototype. We didn't implement the scrolling there, but yeah, we used the AM scripting which is very popular for cross-compiling C++ to WebAssembly, and yeah, it worked quite well. We did the same thing in Rust. Was also a really good experience. And as you can see, we also implemented scrolling. And doing the same with for the desktop was also really easy. And yeah, in the end we decided that we skipped the desktop version for C++. It kind of took, it was a little bit cumbersome getting all the glue and STL and all the OpenGL libraries to work. But I mean, we kind of knew that it would work eventually, and so we decided we don't have to do it fully to the end. Yeah. So currently, what our future integration plans are for the module is we want to. Right now, we have the Java desktop application, which uses the C++ 3D module and is using DirectX underneath. It's integrated with GNI, that's Java native interface. And we add Rapid behind the proxy or facade, because this way we can then, or we already started creating the Rust 3D module. And we basically use the same GNI interface so that the proxy can decide on demand, maybe feature by feature, if it should use the old or the current C++ module or the new 3D module, the new Rust 3D module. So we decided that the current GNI interface is kind of the rigid interface, and when we create the new one, we consider it more the flexible interface, because there were many choices made for the current module. Maybe not always the best ones, but we know that it's working well. And so we didn't want to make the same mistakes again. So we decided we will, for now, make a similar or equal interface. And maybe once we have everything in place, then we can consider also adapting the interface as well. And the new Rust module will then later also allow us to access it from the browser via the WebAssembly interface. And once all the features of the old module are also there in the new module, we can even consider removing the old module, or even the proxy and the facade if you don't need it anymore. Yeah, this is a pattern which is called Strangler Fig pattern. I really like this illustrative analogy. It's named after the Strangler Fig, which starts growing in the top of a tree and grows down and wraps the host tree until the host dies, and basically the tree will be made of the Strangler Fig eventually. So, and this running the old and the new module side by side until the feature parity is reached, there's a couple of advantages. First of all, it reduces the risk of a rewrite project, because when you start rewriting something from scratch, it might take a lot of time until you can actually replace it. And this running it side by side allows you to early figure out if it works in a similar way, or if there are any problems, and you might even already ship it to a customer, or ideally you ship it to a customer as well. Yeah, as I mentioned, you can always compare it with the current production tested system. And it's sometimes easier than refactoring gradually, especially when you switch a language. Then it's probably the best choice, or a better choice. And this is a pattern created by Martin Fowler, invented by Martin Fowler. So yeah, I guess why we chose Rust is probably not so surprising for most of you, but maybe some of our participants have a similar choice and are interested what we found out. So C++ is a very established language and environment. That's certainly an advantage. But with Rust, the compile time is really short, which means less workflow interruptions. So you can more focus during the development and test cycle. You can focus more on the task at hand. It's also a lot easier using third-party libraries because you have a more modern package management system. And yeah, in general, it's a very modern language and provides modern tooling. So the project setup was really easy, and it has a quite standardized project structure, which you don't have in C++. And the strong safety guarantees during our proof of concepts and our first developments of the new module, we never had to fight any null pointer issues except when we share the pointers over the GNI interface, then where you have to go to unsafe land. There you can still have the pain, but it was really, really rare. So within Rust, this is really great. And the platform interoperability, you would have it in C++ as well, but I think in Rust it's even better because all the crates by default ship with the source code. So yeah, in C++ you also have platform interoperability, but when you want to move to a new platform which you didn't support so far, then it can still be painful because maybe you don't have a library yet in binary form for this platform, and you have to figure out how to get it and how to link it and so on. So to sum up, Rust is really awesome, and that's why we decided we will build our new module in Rust. And I also wanted to share what we in the future think will be really nice, will work nice with Rust. One thing that we are looking at is SIMD instructions, SIMD instructions. So maybe if you never heard of it, if you have to process a lot of data and have to do the same operations on each item or each value over and over again, usually have a for loop, and each operation is processed sequentially. But with SIMD instructions, these are low-level processor instructions. It allows you to do the same instruction on 4 or 8 values at the same time. So this really can offer a great performance improvement. And yeah, as when you look at the cats there in the lower row, they are all moving at the same time. So this is of course much more efficient. And there is this feature is still highly experimental in the browsers, but there already is a portable SIMD project from Rust, which might come in handy in the future. Portable SIMD means that it's the SIMD instructions are usually different if you have an Intel CPU or ARM or AMD CPU. So usually it's not really portable, and it was always having a portable library where you write your SIMD code once and you can use it across operating systems and across different processor technology was always really difficult. So we are really looking forward to take advantage of this one. I wanted to do a short recap why the performance requirements are high for us. So the volume can be really big. So each slice has often 512 by 512 pixels, and having 1,600 slices in a volume is not that big already, and this would be 800 megabytes in memory or on the GPU. Also, if you have a full screen rendering of a full HD resolution, it would mean you have to virtually shoot 2 million rays for each pixel. For each pixel one ray, and the diagonal of that volume is means that you have, in the worst case, 1,700 steps for each ray. And for interactive visualization, when you rotate the volume or zoom in and zoom out, you want to deliver interactive frame rate of 30 to 60 frames per second. So yeah, these are not yet the most extreme scenarios, but yeah, of course, there are some optimizations you can apply, but performance is really critical for our module. Also, what we are looking forward to is using WebGPU in the future, and there is already a great library developed by Mozilla, the vGPU RS, and WebGPU offers a modern graphics API for the web, and is inspired by Vulkan, Metal, and DirectX. Just 1 or 2 weeks ago, the first public working draft came out, and it's already available via preview flags in the preview browsers. So it's also quite experimental so far, but there is a lot of things going on in this direction. And the community is growing, which verifies to us that Rust is definitely the right choice, and also many big players are actively supporting it. So our current and our next challenges, we restarted with production quality requirements. This meant for us to really get the Rust specific skills to mastery, which some things we could ignore quite well for the prototypes. And also the integration in the different application can sometimes be a challenge. And also static code analysis is something we are still developing. Rust Clippy is great. It offers a lot of value during development. And I just found out that there is already a community library for supporting Zona Source, which we use in many other projects as well. So we have a combined reporting for our static code analysis of our project as well. So before wrapping up, I also want to mention that we are hiring. So if you love Rust as much as we do and are interested in medical visualization, join us at Dedalus and support us in creating great software. And also working remote is definitely an option, as I do as well. As I mentioned, I'm based in Scharnstein, Austria, but our office is in Vienna. So I'm usually there for a couple of days per month. And here you also find our contact details if you want to reach out to me on Twitter or via email. Also to my awesome coworker, Katharina, who is not able to be here today. But also yeah, we took a great part in our preparing the presentation. Thank you very much. Now I'm looking forward to all the great questions.
Awesome, Harald. Thank you very much for the presentation. It was really interesting. Rust isn't it is an established language, but it isn't as classical established like C, C++. So it's always very interesting to hear real life stories and to hear established companies betting the farm on a programming language like that. I mean, it's a very important field that you are working in, and hearing that you are considering Rust, playing with Rust, and planning to use Rust is super interesting. Let me start with one question that follows up on your, I think it was the second last slide. You are hiring, you said. What is your experience in Austria? You are a company in Austria. You are offering Rust jobs. Is there already a market for Rust developers? Do you get a lot of resumes to take a look at? Is it hard to find experts in this area? Can you share your experience a little bit? I bet a lot of people in the audience are interested in, maybe they are looking for Rust people, or maybe they are offering Rust expertise to companies. So maybe you have some thoughts about that.
Yeah, I think the Rust community is not that big yet, but the cool thing is the candidates they're usually very excited and very motivated. So I really like that. And yeah, it's the first time we are looking for Rust engineers, and yeah, I think it's growing, and more people will join this technology.
Oh, interesting. Very interesting. We have one question from the audience, which has not yet been answered. Koshikim, I'm not sure how to pronounce the name. Maybe it's an abbreviation. He or she is interested in where to find additional information about compilation time, comparison between C++ and Rust. Do you have any numbers to share, or can you elaborate a little bit more about your experiences, the experiences of your team in terms of compilation time?
Unfortunately, I cannot share any numbers, but I think what I experienced is that incremental compilation is a lot better with Rust. Yeah, I think as far as I remember, C++ kind of has the problem that the header files need to be parsed. I think they block the language with improving the compilation time to some extent. I think there are some ways to work around it and so on, and there are some clever techniques that this is less of an issue, but I think C++ was not able to completely solve it. Maybe if the new C++ modules kind of reduces the pain to a smaller scope, but the pain is still there, I guess. And this is something I realized in Rust is really smooth.
Okay, thank you very much for this insight. It's, as I said, always interested to hear about Rust in practice. I currently don't see additional questions, so I have 2 questions left. They are more of the organizational part. Harald, I think you are already on our Discord server, right?
Yes.
Awesome. So if people have questions or would like to exchange experiences, they can get in contact with you via the Discord server. And I think if anybody is interested in working with your team, they can also approach you via the Discord server. And the second thing is, it would be awesome. I don't know if that's possible, if you would share the presentation with us. So if that's possible, it would be great if you could maybe share a link to the slides with the Discord, because you have awesome visual material in it. And if somebody is interested in that material or would like to convince his or her team to that Rust is really interested, then maybe your slides will be of great help.
Yeah, sure. I will get back to you right afterwards, and I will also turn on my Discord application right after this talk.
Okay, thank you very much, Harald. We really enjoyed having you here. Thank you for taking the time for doing this awesome presentation, and I wish you a good evening. Good evening to Scharnstein.
Thank you very much. Thanks a lot for building up this great community, and yeah, having such great talks at your meetup.
Thank you very much. Thank you, Harald. And with that, our Rust meetup is over again. It was the 10th Rust meetup here in Linz. Thank you very much for watching. Thank you for being part of this community. If you want to stay in touch with us, don't forget to join our Discord server. And for me, it's just to say thank you, wish you a nice evening. Remember, the June edition of the Rust meetup Linz will be the New Zealand edition. So we will start late at 10 p.m. in the evening. Still, although we start at 10 p.m. we hope that many of you will join us again for 2 very interesting sessions. We'll stream live from New Zealand. So enjoy the rest of May. See you in June. Have a nice evening. See you. Bye.